Hello everyone. In this video, I'm going to walk you through question SQ3 of our special antenna exercise. In these questions, you're given an antenna array, but the antenna array is not in XY plane. It is in ZY planes. So it's quite tricky. And also, the excitations of the array elements are not all equals. Say for this one, the excitation is 1, 1, and this one, the excitation is -1, -1. And in the middle, in the center here, we have another antenna. The excitation here is -2J. So the question is very tricky. An array of two isotropic sources consisting of 5 elements, a space with equal spacing d. So the spacing is d. The elements excitations are as follows, and find the array factor. So we need to do something for the array factor. And now we also need to find the smallest spacing d, such that uh, when the angle is when the angle theta is 45 degree and angle phi is 0 degree, then you produce a nu. So you need to use the spacing to combine it with this angle to form a nu. Yeah, I think we can start now. So to begin with, let's recall what we have learned from the previous video. First, in any randomly chosen direction, it has a vector. The direction can be represented by the vector, but the unit vector, there's a formula for the unit vector, and I'm going to write it down without any derivation for this formula. Yeah, if you have any problem with this formula, then you just go back to watch video SQ2. Okay, so let's start now. First, for SQ3, we need to know the vector, the unit vector pointing to the direction of propagation is R naught, R naught hat, x theta cosine phi plus sine theta sine phi, and then plus z hat, and then cosine theta. You don't really need to memorize the formula. It's very easy to derive it. Now let's write down the diagram of the array distribution. So we have a z-axis and we have a y-axis. and we have a element in the middle, and it is driven by minus 2j. And right here, we have an element here driven by 1. And this antenna is 1. This antenna is 5. And there's another antenna here. And this antenna is driven by 1 as well. And you have another antenna. And this is antenna 4. And it's driven by minus 1. And you have another antenna here. And it is 3. And it is driven by minus 1. And the spacing here is all T. T, 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 T. So I hope this diagram is clear enough for you. Now let's write down the array contribution. So for arrow of 1, we have 0 because the coordinate here is at the origin. And we have arrow 2. Arrow 2 is z hat, and then times d. And then we have arrow 3 minus z hat, and then times d. And then we have arrow 4 and then minus y hat times d. And then arrow 5 and then y hat times d. So I have already written down all the I've already used the vector to represent all the antenna coordinates. Right now, what we are going to do is to work out its projection in the direction of propagation. It is the way how we do it is we dot product with our log head. So dot our log head. So 0, then this one has got to be 0. And this one arrow 2 and dot product with this one. And then we will get arrow head. And then minus d cosine theta. And then we have arrow 4 arrow 1, arrow 2. So where is arrow? Sorry, arrow 2, it should be d cosine theta. So arrow 3, arrowhead is minus d cosine theta, and arrow 4 dot product with arrowhead is going to be minus d, this one, sine theta sine hat. And then arrow 5 dot product with arrowhead, and then this one is d sine theta sine. Okay, so now let's take a look in the array vector. The array vector is AF, and then let's start from the first one. The first one has the magnitude 2J, and then the phase here is J0, K0. The second one is this one here. The uh, excitation for the second one is here, is 1. Okay, and then the second one, the cosine theta. And the third one has a excitation -1. So -1 J K D, and by the way, this is minus, right? Cosine theta. And the fourth one has a excitation -1. So -1, and then the phase K, the fourth one, yeah. So minus K D sine theta sine phi. And then the last one, you check the excitation first. Excitation for the last one is 1. So +1 E, and then J K D, and then this value sine theta sine phi. Okay, so we are going to simplify the equation. For the first term, it is e to the power 0 is 1. So minus 2j. The second term and the third term can be combined. When you combine it, then it will become 2j sine k d cosine theta. The fourth term and the fifth term can also be combined. So if you combine this, then you will become 2j sine, and then kd sine theta sine phi. So the first part of the question is done. We can simplify this. We can, because they are all of the terms contain the coefficient of all of the terms in this equation as 2j. We can take 2j out, and then the first term, and then the second term, kd cosine theta, and then minus sine kd sine theta sine phi. So it's exactly the same as the answer as provided. Okay, so I will assume the first part of the question is done. This is part A. If you have question, you can raise your question in the comment section. Now I'm now dealing with part B. Part B of the question. When theta is 45 degrees and phi here is 0. So the first term here had nothing to do with phi. I will just write down here AF become minus 2j, and then 1 minus, this one here. Cosine 45 degrees is 1 over square root of 2. So I will write down here sine k d root 2, and here sine phi is 0, and the whole term becomes 0 because of sine phi becoming 0. And if this is the whole bracket, the term becomes 0, then the sine of theta, sine of the bracket, the term was all 0. So we can just write 0 here. And let's do further calculation. We want the nu to occur at this point, so we write down 0 at this point. So in this case, we have a very simple equation. So obviously, you need to solve this equation. We can say 1 minus sine kd over root 2 is 0. Okay, then you don't need to even argue. I can say this. So this means kd divided by square root of 2 is equals to, say, pi over 2. And in this case, k here can be written as 2 pi over lambda. So we can calculate by our calculation, d is equals to lambda divided by 2 square root of 2. So our job for the second part of the question is also done. Okay? So I have highlighted the answer for the part A. It's written here. If you have further questions about this question, please leave your question to the comment sections. Thank you very much. Bye-bye.